Hello engineers, welcome to the new video of the course, and in this particular course we are going to discuss the second and third point, that is semiconductor acts as an insulator and as a conductor as well, and it is used to control the conductivity. Okay, so we are going to discuss this particular concept in detailed way, but before that let's quickly revise what all things we had seen in our previous session. So in the previous session we actually saw that semiconductor. Okay, so what is the difference between conductor and semiconductor, or rather what is the difference between electrical circuit and electronic circuit? So as far as electrical circuit is concerned, so energy, it can be any energy, it can be a thermal energy, it can be a heat energy, it can be a electrical energy. This energy is passed only because of electrons, right? So when your electron is moved, so obviously the thermal or the electrical energy is being passed. But in case of semiconductor, or rather in case of electronic circuits, electrons and holes both are equally responsible to pass this particular energy. Okay, let's suppose if you want to pass certain electricity through a semiconductor, so both electrons and holes should move. Okay, should move. Obviously they are going to move in the opposite direction, that we are going to discuss in the upcoming session, so you don't worry about that. But the most important thing is that both are equally responsible to pass the energy as far as electronic circuit is concerned. Okay, or rather that is the differentiating factor in between conductors and semiconductor. Okay, and that's why semiconductor acts as a foundation for the electronic circuits. Great. Now let's proceed further and let's discuss upon this particular point, that is what was that point? I just forgot. Anyway, so it acts as a conductor and as an insulator as well. Okay, so we are going to discuss this particular point, that is conductor and insulator. Okay, so for that let me just write over here semiconductor. Now I'll just break this particular word into two parts. So if you look very clearly, that this is semi. What is meaning of semi? Semi means partial, half, right? Half or partial. So semi means partial. And what is conductor? Which is responsible to conduct. It can conduct anything, but specifically it is responsible to conduct energy, right? Conduct energy. Now since we are dealing with current, electricity or electronics, so we will just write it in simple way, that is electricity. That is nothing but energy, right? Conduct current, electricity, you can say anything, to conduct electricity or to conduct energy, right? So what does that mean? So basically semiconductor is a device which partially act as a conductor and at the same or it can partially act as an insulator, right? I hope you are getting my point. See what I did, I just wrote this particular word semiconductor and I just broke it into two parts, that is semi and conductor. Semi means what? Partial, and conductor means what? It can conduct electricity. So with this particular word, what I can guess as a layman, what I can guess is that a conductor, it is partially acting as a conductor and it is partially acting as an insulator. I hope you are getting my point. Okay, again I will repeat. So basically semiconductor is a device which acts as a conductor as well, and it acts as an insulator as well. As the name suggests, partially conductor or partial, it can partially conduct electricity. Great. So the very first point that I understood as a layman, okay, now we don't have any idea about what exactly a semiconductor is, right? So the very first point that I can guess is semiconductor, let it, okay, it means semiconductor. Okay, it is a device, it is a device. Semiconductor is a device which behaves as a conductor, and an insulator, Great. Insulator. Okay, now add one more point from my side, and that is this. Although we are going to discuss this particular point in the upcoming session, you don't worry about that. And the point is, but it won't behave as a conductor, and an insulator at same time. What does that mean? That means at one particular time you can operate your semiconductor as a conductor or an insulator at same time. Let's suppose at given particular time or at given time you cannot operate semiconductor as conductor as well and insulator as well. You can either operate semiconductor as a conductor, okay, or else you can operate semiconductor as an insulator. Okay, now who will decide that my semiconductor it is going to operate as a conductor or it will operate as an insulator? Okay, so there would be one parameter which will govern or which will tell me that my semiconductor it will operate in the it will operate as a conductor and it will operate as a insulator. So let me write that particular point as well. So by altering certain parameter, by altering certain parameter. Now we don't know what exactly that parameter is. By altering certain parameter, let's assume that parameter is P. Okay, by altering certain parameter, we are behaving semiconductor, I'm writing it in short form as an insulator, or conductor. Okay, again we will quickly revise this particular point. I know you might have got stuck over here that how exactly without giving any proof sir is telling that your semiconductor can't behave as a conductor and insulator at the same time. Don't worry, I will give a legitimate proof in the upcoming session, in the upcoming video. Don't worry about that, just have belief in me, okay, have faith in me, and just we will quickly revise this particular point. What I did, I just wrote this particular word semiconductor. What is semi? Semi means partial. What is conductor? Which can conduct energy, right? So it can partially conduct electricity. Energy means electricity. Obviously we are dealing with electronics, so it will partially conduct electricity. This is what semiconductor means, right? That means what? The other thing is that partially it is acting as an insulator, right? If partially it is behaving as a conductor, so that means partially it is also acting as an insulator. So that is the main idea over here. So that's why I had written it is a device which behaves as a conductor and an insulator, right? But I added one more point, that is it won't behave as a conductor and an insulator at the same time. Okay, so maybe at a given particular point you can operate semiconductor as a conductor or an insulator. Okay, great. That means what? We have to alter certain parameter, right? By altering certain parameter, we are behaving semiconductor as an insulator or a conductor. Now we don't know what that parameter is. It can be any parameter. Now since we are dealing with current and electricity and electronics, so obviously the parameter can be a current, it can be a voltage, it can be a power, it can be anything. Right now we don't know. Okay, right now we don't know. So let's move further and let's discuss this particular topic in little detailed way. Okay, so this is just a short diagram, or you can just take it as a short graph which will help you to understand or to grasp this particular concept in detailed way. Okay, so let's assume this is my parameter and this is your semiconductor, right? Let's assume I want that my semiconductor should behave as a conductor, right? So what I will do, I will just vary this particular parameter. I will make sure that this particular parameter should move in this particular direction, right? And if this particular parameter, if it is moving in this particular direction, let me use this particular arrow which is already being given over here. So yeah, okay, so let's suppose if I want to operate this particular semiconductor as a conductor, so I will move this particular parameter to the left side, right, to this particular side. And when I do this, what I notice is that my, just a second, let me take some different color. Maybe I will go with this one. Yeah, okay, so what I see is that the insulating property of the semiconductor, it decays, okay, or it decreases, whereas the conductivity property of the semiconductor, it increases, right? Great. I hope you are able to understand this. Don't worry, I am going to discuss this particular point in detail as well, but as of now just try to understand this particular point. See, when I am trying to move this particular P parameter, it can be anything as I discussed. It can be a voltage, it can be a current, right? If I am trying to move this particular voltage towards this particular side, so the conductor property or the property of the conductor, it is going to increase, and its insulating property, it is going to decrease, right? Now let's suppose on contrary, if I'm trying to move this particular parameter in this particular direction, right? So what is going to happen? This time, what is going to happen over here? The let me again take this particular color. Yeah, this time what is going to happen? The insulating property, it is going to increase, whereas the conductor property, it is going to decrease, or it is going to decay, right? This is very simple and logic, right? If I want to operate my semiconductor as a conductor, so obviously I need to move this particular parameter in this particular direction, so that my properties of conductor will increase and the insulating property will decrease. Whereas if I want to operate this particular semiconductor as an insulator, so I need to move this particular parameter, it can be voltage, it can be current, in this direction, so that its insulating property will increase and its conductor property will decrease, or conductivity will decrease, right? I'll come to that particular point. Okay, so now we all know, since in the course 1 only we had discussed that my conductivity, what is conductivity? See, we had always show conductivity with this particular sign. Okay, conductivity, it is reciprocal of resistivity, right? So if my conductivity is increasing, so my resistivity is decreasing. If my resistivity is increasing, so my conductivity will decrease. So they are reciprocal of each other, right? Great. So just let me just highlight it. Let me just write over here. Those students who don't know this, for them I'll just write it over here. So this is my conductivity. This is my conductivity. I'm not discussing this particular parameter over here because I had already discussed upon it in my previous course. Okay, and this is my resistivity. Now if you look over here, if I'm trying to move my parameter to the left side, so what I can say is that my conductivity, let me write over here. Yeah, my conductivity, it is increasing, whereas my resistivity it is decreasing, right? My resistivity is decreasing, right? You can clearly see over here as I'm moving to the conductor side. That means if I want to operate this semiconductor as a conductor, so I need to increase its conductivity and I need to decrease its resistivity, right? On contrary, let's suppose if I want to operate this particular semiconductor as an insulator, so in this scenario I need to increase its resistivity, right? I need to increase its resistivity, and if my resistivity is increasing, so automatically my conductivity is decreasing. That's great. Okay, I hope you are able to understand this particular concept. Great. Now when I say that my resistivity is increasing, so what does that mean? That means, again, as I had discussed this particular formula in the very first course, that is R is equivalent to rho L by A. So the formula for resistance is R is equivalent to rho L by A. So you can clearly see, as my resistivity is increasing, so my resistance also increases, right? As my resistivity increases, so my resistance also increases. What does that means? That means your semiconductor will behave as a infinite resistor or a strong resistor, or it will provide a very high resistance if its resistivity is increasing. On contrary, if its resistivity is decreasing, so it will provide negligible resistance. Okay, that means it will act as a conductor. Okay, I hope you are able to understand this particular concept. Again, we will quickly revise what all things we had discussed in this particular slide. On this particular slide, see, this was just a small graph, that is conductor, insulator and semiconductor. Okay, we need to alter certain parameter to behave this semiconductor as an conductor, or to behave this particular semiconductor as an insulator, right? Then we discuss this particular formula, that is conductivity is equivalent to rho L by A, right? And with this we can easily say that if I'm moving this particular parameter over here, that means my semiconductor is acting as a conductor, right? If my semiconductor is acting as a conductor, that means its conductivity is increasing, right? And if its conductivity is increasing, right, that means its resistivity is decreasing, right? Great. Okay, so now you have to apply exactly opposite concept if you want to operate semiconductor as an insulator. So when I say that I want to operate my semiconductor as an insulator, so that means I need to increase its resistivity, and when I do that, so automatically its conductivity is decreasing, right? And the another thing that we saw was this, that is rho L, resistance R is equivalent to rho L by A. That means if resistivity of my semiconductor, it is increasing, so it will provide high resistance. I mean, the semiconductor will provide high resistance. That means it will behave as a pure insulator. On contrary, if my resistivity is decreasing, so my semiconductor, it will behave as a pure conductor. It will allow that means the resistance would be negligible, and it will allow maximum energy to flow through it, or maximum current to flow through it. Okay, so I really hope that you understood these two concepts. That is, it acts as a conductor and insulator, okay, but at different time. Okay, you cannot operate semiconductor as a conductor and an insulator at the same time. It will operate at a different time. It is used to control conductivity, as mentioned over here, just by altering certain parameter. Again, I had not discussed what that parameter is. It can be a current, it can be a voltage, right? But there is surely one parameter, okay, which is going to control the conductivity, right? Which is going to control the conductivity. Okay, great. So this was all about the 2 points, that is, acts as a conductor and insulator at different time. I had intentionally not written over here, and it is used to control the conductivity. Great. So I really hope that you understood the very first 3 points. Okay, but still, if you have any doubts, if you are facing any difficulties anywhere, it's my request to you, please ask me in the communication section. I will surely help you out there. Okay, so thank you for listening me patiently. I'm ending this video over here. Thank you.